Okay. Good morning, good afternoon, or good evening, everyone, from wherever you're joining us in the world. I've gotten so used to saying that over the last 2 years. My name is Jason Walls from Café, and thank you for joining our one of our Connected Home webinars today from the Broadband Forum Connected Home Council, increasing services and intelligence through a USP bulk data collection. We're going to talk about the bulk data collection mechanism and how it works and the primary use cases for it. I will get started. So like I said, I'm Jason Walls from Café, and I am one of the Broadband User Services Work Area Directors at the Broadband Forum and Chair of the Connected Home Council. And I'm going to go through the introductions of our speakers, as well as the Q&A at the end. And I'm going to do a quick little overview, just a reminder of what USP is and the building blocks that make it. Then I'm going to hand off to Tzvi, and he's the VP of Product Management at Friendly Technologies. Friendly has been working very closely with TR-369 USP and how to build good solutions that can use all of this intelligence. And he's going to go over some of the operator use cases for bulk data collection and kind of explain the why of how that all works. And then John is going to go, John from CommScope, who is my partner in crime at the Broadband User Services Work Area, and also, has been involved with the Broadband Forum for a very long time. He is going to actually dive into how bulk data collection works in USP and all of the different mechanisms that you can, all the different knobs you can turn to get the results that you want. Okay, so let me just go over this really quick. People who have been on any of our recent webinars have probably seen this slide before. This is just an overview of the standards that make up the user services platform. So obviously everybody knows TR-369 is the document that defines the protocol itself and the architecture and the messages and how all of those things work together. It is also where we give the theory of operations for bulk data collection. So you can find it in that document. The objects and parameters used for configuring bulk data collection are, of course, in TR-181, which defines the data model. In addition to all of the other stuff that we have defined in there, like the KPIs for various interfaces, including all the Wi-Fi stuff we just added with WFA, stuff like that. That is all complemented by the certification program, which is the test plan of which is defined in TP-469. And we have some bulk data collection test cases in that certification program. And then, of course, this is all helped along by the reference implementation defined by the OB USP agent open source project that is handled by the Broadband Forum. Just to see how this kind of looks when it's all working together today. Again, a lot of people might have seen this slide before. This sort of defines how USP controllers and agents work together, but also, these other components. So today we're going to be talking a lot about this, right? So this is a service that's working as a data collector. It might also be a USP controller receiving USP notify messages with the bulk data content. But it can be an entirely separate entity that is collecting bulk data over HTTP or MQTT. So that's what we're going to be talking about today. All right. Without further ado, Tzvi, would you like to take over from there?
Yes, thank you. Thank you very much, Jason. Let me just grab the screen. So I hope that everything, thank you all for joining, and I hope that everything is working okay. Thank you, Jason, for this great introduction. And I do want to take us today through the journey that we had with bulk data collection and why we find this very exciting and very promising also for the variety of different service providers that we are serving, and we are using these implementations in order to get them more engaged into the service intelligence era. So we all know the assumption that the service provider wants to offer more services to increase ARPU and reduce churn, right? This is the main idea for all the service providers. And we have seen the role of the service provider transitioning from their traditional responsibility, previously only limited to the edge, to the customer premise equipment, now being penetrating the home with Wi-Fi, smart home applications, home security, and other services as well. So as you are all aware, the challenges that were presented with these transitions are primarily to providing a stable and secured and a very efficient communication channel. Reduced churn is one of the main topics even today in the era, and it becomes even more relevant for the service providers as they're offering more and more managed services as altogether. But with the increase of those services and application, there is also an increase in the need of collecting data and monitoring that and getting the service intelligence. We need to provide efficient tools, not just for managing the device, but also for collecting the data and providing service intelligence. So service providers are always looking for better tools to manage control, while still one of the most important things that we must understand is that they need to ensure the quality of the experience and the overall network infrastructure and usage, and including also the service level. So the customer service experience has a direct impact on what we see as a customer satisfaction and churn. This is why CSPs need to maintain a reliable connectivity and a very high quality and stable Wi-Fi if they're offering the Wi-Fi solution. And also the ability to monitor and collect performance KPIs across various services which are building the service intelligence. So they're also looking for a proactive response based on AI and ML capabilities. We need to identify the service degradation before it happens or at the time that it happens in order to have a proactive resolution before the customer is actually experiencing some outage or a decrease in service level. So how can we collect all of this data? As we have grown with the number of services that we are providing to our customers, how can we efficiently collect the data without influencing the operational level that and support that the service provider is offering? This is the most important thing for most of the service providers. The provision and CPE, the provision and manage the CPEs is a crucial path in maintaining a customer satisfaction. And the main point here is that we need to balance between monitoring and collecting data while still maintaining a very high level of operational and maintenance availability. That's a crucial path with every service provider today. And this is a challenge for all service providers. So with this challenge, USP actually offers a solution with bulk data collection, and we will touch this very widely today, and we will go and deep dive with it. So let's take a closer look at the previous architecture that we had with TR-369 and the approach that we had till USP bulk data collection came. So a quick journey down memory lane. The current CPE deployment that we see, we know that the CPE supports a single ACS that he can interact and communicate with in order to send management and also events performance events that the CPE collects. One solution that most of the service providers are taking today is the usage of a network load balancer in order to steer the traffic and distinguish between the management and operation related traffic and the monitored events. So in order to do that, we must maintain a network load balancer with a layer 7 application that could parse the information and steer the traffic based on TR-69 XML, which means that we need to distinguish between some monitored events, like we all know them from TR-69, which are, they could be 2 periodic and 4 value change, which indicates when a device is arriving to the system with some information that he wants to share with the ACS or a diagnostic complete. These events will be passed by the network load balancer and will be sent to a different set of collectors within the network. But we must understand that the CPE can perform only one task at a time, which means that if he's sending this information, he cannot perform the provisioning and management tasks. This is a very big downside, and we will also touch base with this during today's presentation as well. So, with this network distributed architecture, the service provider achieves the goal of maintaining the separation between the management and provisional interface and the monitored interface. But there are challenges as well. The challenges are that there is a cost for this. We need to maintain a network, a layer 7 application, a load balancer in order to route the traffic accordingly. The device management platform itself, the ACS, should be aware of any change that comes, and the information should be also synced between the ACS and those servers who are collecting the QoE, the quality of experience server, which is collecting the information, because we don't want to lose those devices from the network. So there should be also a sync mechanism between them. And this actually does require additional infrastructure, servers, network elements, and so on. On the device, still the device, as I mentioned before, it can perform just one task, either provisioning or monitoring. It cannot do them at the same time. And still we have just one address that the device can communicate and work with. So how can we actually overcome this challenge, and what USP bulk data collection brings to the table here? The Broadband Forum has introduced a new approach for collecting data from the CPE. The theory of operation can be widely accessed, and it is available for everybody to use in Annex A, if I'm not mistaken, for the for TR-369, which is USP. And it is also fully compatible with a cloud integration, and I will also discuss about this in the future. So the mode of operation here actually is different than the one that we saw before. With the support of bulk data component on the CPE itself, the CPE can steer the information to the bulk data collector. That is the main approach here. This could be done over HTTP or MQTT. This will be widely discussed in this session as well. And we can specify the bulk data collector address. There could be even more than one collector according to the customer needs. He can have various collectors for various different profiles and so on. With this method, the CPE collects and transfers the events, the performance events, to the data collector. There are several methods of transport. You can use HTTP or MQTT. You can encode the data using CSV or JSON. And I know that John will touch base with that very shortly. So this approach gives us the ability to efficiently distinguish between the provisioning and management data from the monitored events that the CPE will send. And the CPE can still perform any provisioning task that is required by the controller, by the USP controller as well. And so we are getting a very efficient way of distinguishing between management, provisioning, and the monitored events. This will provide also a distributed service defined environment while maintaining a very high availability of operational service. So, and we will be able to accommodate a very high load of monitored data. This could be from a single second or a minute into which a relevant time interval that the service provider is looking for. So, and why is this so exciting for me to discuss with you today is because we actually started this conversation, I think somewhere last year, with one of the service providers that we're working with, because he had the same requirement. He was looking exactly for this kind of a solution. So what I wanted to very quickly try to show you the use case that we had to accommodate here. So let's take this following use case as an example. We had an ISP with approximately 2 million subscribers, providing high-speed fiber, Wi-Fi and mesh devices, voice services, and also TV and entertainment. So far, it is like every ISP or most of the ISPs around it. So they were looking for a better way to collect the CPU-related statistics for ONT and Wi-Fi, and they were looking to get more information on customer satisfaction and reduce Wi-Fi-related support calls. We all know that among the top-rated complaints today to the support, to customer support, is that I have a problem with my internet, right? My internet is not working, it's very slow, and so on. In most cases, the problem is related to your in-house Wi-Fi configuration, setting, interference, coverage, and so on. So this can be easily also addressed and monitored using bulk data, and I will try to describe this. So actually, he came with a requirement saying, look, I want to monitor the CPE every 15 minutes. And I want to get this amount of data, these KPIs, I want to be sent to us for every 15 minutes. What would be the best way to do that? Of course, this would be a bulk data collection. So how does this would work, in a nutshell, because I know we have a very extensive presentation today in a session to describe bulk data in more details. But in a very, a high level, I'll try to shortly explain this. Bulk data can actually be set through doing a few short steps, creating the bulk data profile, setting the collector address, setting the report encoding if you want to use CSV or JSON, setting the transport that you would like to use. It can be either HTTP or MQTT, and John will touch base with that. And then just setting the monitored parameters, which is very easy, which parameters you would like to collect. So if we are interested in Wi-Fi, and that was the main goal here, to monitor this, actually we can collect over 250 network performance measurements. And this was achieved due to the collaboration that we have between the Broadband Forum and the Wi-Fi Alliance device-to data model that Jason described before, is constantly evolving and adding more and more object and parameters in order to monitor efficiently the Wi-Fi and other related interfaces within the CPE. So this can assist us with resolving Wi-Fi coverage issues, providing proactive tools for the CSP to identify a potential service degradation. We can collect performance metrics and show them over time. We can also create a user score based on those collected metrics, right? We can set, okay, if a user is now downgrading and his score is being reduced, maybe it would be best to have a proactive approach to check what is the use of that. Maybe he has some problems with his indoor coverage, maybe Wi-Fi interference coming from one of the neighbors, and we can change the Wi-Fi channel, for example. That would be a very simple task to execute. So assuming, apologies for some background noise here. Yes, apologies for that background noise. I think it's gone now. So this could assist us with Wi-Fi resolution and optimization. We can collect key performance indicators that are described in TR-181, and you can use them. This would not require any additional client to be onboarded on top of the CPE. You can use the same USP agent in order to continue and collect and set the CPE to collect this information and send this information to the bulk data collector itself. The indicators can be used to assess the service, the service level, the radio interference, and also assess the associated devices. You can have a better view of your indoor Wi-Fi user experience. You can also measure all of the measured Wi-Fi objects can be used to provide a full network discovery as well, to define relations between various network interfaces, if you have a mesh, an easy mesh installation within your home and so on. So there are a lot of things that we can accomplish using this, and all of this information, as I mentioned before, can be collected, monitored, analyzed for a better service. Another important measurement that we can take under consideration here is the use of CSP's compliance for speed and latency. The data can be pushed to the collector and then visualized by various applications, support tools, and even third-party BI applications. So I hope that this was, a quick journey with one of the use cases that I found that could be very interesting for the industry as well. And I will hand it over to you, John.
All right, thank you, Tzvi. And thank you, Jason, for the nice introduction. And thank you, everyone, for joining us today. Just bringing up the presentation here. All right, so this portion of the webinar, I'll jump into how bulk data collection actually works. I'll get into a little bit of what I would call an introduction to bulk data collection, and then we'll jump into some of the different protocol options. Then we'll do a bit of a comparison between the different protocol options, and then we'll get into data encoding and the various options we have there, then how we actually reference the data model, and then get into a portion of the bulk data collection mechanism called alternative names that may help reduce the size of your telemetry reports. So to start off, what is bulk data collection? I like to kind of, boil it down to just a very simple kind of concept, which is the ability to configure the CPE to send telemetry data on a consistent basis. And there are four key aspects to that. You need to determine, what data needs to be collected. So that's going to be the parameters that are going to be included inside the actual telemetry report. You also need to figure out how often you want to deliver that data, the frequency of the telemetry report generation and delivery, where you want to send the data, what's going to be that destination, that bulk data collector, and how to send the data across the wire. So this is, talking about the protocol to be used, whether that's HTTP, MQTT, or the USP event notif mechanism, as well as how to encode the data and how to format the report. So we'll get into a lot more detail around those aspects through the rest of this presentation, but just a quick note before we jump into that. The streaming and file protocol options that were seen in the TR-369 world for bulk data collection weren't actually carried over to USP. And they've been deprecated in the latest version of the data model, the device 2.15 version. They'll soon be obsoleted and eventually deleted. All right, so moving on, I like to break the different protocols for bulk data collection out into two different categories: the out-of-band communications and the in-band communications. To start with, HTTP and MQTT would be considered out-of-band communications. And they work fairly similarly. Basically, your USP controller is going to configure the USP agent for a bulk data collection profile, which defines all the different aspects of what data to send, how to send the data, how frequently to send it, and where to send it. So once that is configured inside the USP agent, and then a time comes when the USP agent needs to generate and deliver a telemetry report, in the HTTP aspect, it will just send an HTTP post out to your bulk data collector. This is all very similar on the MQTT side. You still do the configuration via the USP management and its communications channel, but instead of sending an HTTP post, you're going to send a MQTT message to your MQTT broker, and your bulk data collector will be connected to that broker as well and receive those reports. So basically, these are out of band because the telemetry reports are being sent via a separate communications mechanism that is not the USP management channel. And then if you look at the USP event notification mechanism, which is the in-band version of bulk data collection, it starts off with a very similar way. Your USP controller is configuring that bulk data collection profile via USP. But the difference here is that instead of sending it through some kind of out-of-band communications channel, it's actually just going to simply deliver that telemetry report via a USP notification. It's a USP event notification specifically. So the actual complete content of the report is sent across that USP notification to the USP controller. And now the USP controller has an option at that point. The USP controller can consume that telemetry report and do with it what it needs to, or it can actually forward it off to a bulk data collector if it needs to. That mechanism of forwarding it off to a bulk data collector is not covered by the USP specification, so that'd be something outside of what USP defines. So do a little bit of a comparison between the various options here. You look at your out-of-band communications, your HTTP and MQTT. Your advantage is that it's you have a separate management traffic from your telemetry traffic. But likewise, the disadvantage is that means you have to have an additional communications channel present between that CP and the cloud environment. And just a side note on HTTP versus MQTT. MQTT utilizes a persistent connection. So that means that every time you only do the auth once when you do a connection, you don't have to do the auth every time you send a telemetry report. Whereas HTTP being connectionless, every time you do a report delivery, you have to do the auth. So back between the comparisons, on the in-band side of things, the USP event notification, you're using a single communications channel for both management and telemetry traffic. So you don't have to have two separate communications channels, which leads to potentially, the ability to do fairly frequent or efficient telemetry delivery, because each telemetry report doesn't have to go through the whole process of kind of establishing a communication session and authenticating and everything. But I would also note that that's also kind of an advantage of the MQTT side of things too, as I noted in, earlier. The disadvantages is that you're restricted to using the USP controller that actually created the bulk data profile. This was something that the Broadband Forum put in to kind of make sure that we have some security around what USP controller is allowed to receive which data, and so that you couldn't get around the access control permissions and so forth. Another possible disadvantage here is that you're combining your management traffic and your telemetry traffic on the same communications channel, which can sometimes result in traffic being impacted, specifically management traffic being impacted due to the sheer volume of telemetry traffic that you might be sending across that same channel. So if you kind of take a step back and look at that, HTTP definitely has the advantages of separate management, but requiring an additional communications channel. MQTT has the same, but MQTT kind of picks up some of the advantages of in-band, since you don't necessarily have to do auth every time you want to send a telemetry report. All right, let's jump into some data encoding options. We basically have two different data encoding options here, JSON and CSV. And under each, there's two different report format options. The JSON has object hierarchy and name value pair, and CSV has parameter per column and parameter per row. So we're going to get into each one of these and show some examples in the next few slides. Let's start off with the JSON object hierarchy option. So here you can see on the right-hand side an example of a JSON telemetry report, very simple, that has some device.mocha.interface.1.stats parameters inside its actual report. And so you'll notice what's happened here is that typically in kind of a Broadband Forum TR-369 USP parameter path, you would have all these different components separated by dots. And so it would definitely look like device.mocha.interface.1.stats.broadpacketsent. So this particular object hierarchy is basically separating each one of those dot separated components and putting it into a JSON object, and then putting it into a hierarchical structure, so that essentially you're saving a lot of space on the wire, because you're not repeating that device mocha interface 1 stats for every single one of those parameters. Then if you look at the name value pair, this kind of is the opposite of the object hierarchy, in that you're basically just sending the entire parameter name and path inside of each one of the entities in the report. And so you're definitely going to have a lot of duplication of things like the device.mocha.interface, as you can see there. Sometimes this is easier to process on the other side, and the extra kind of content can be taken care of via compression algorithms and so forth. So it just depends on which way you prefer to receive that data. Then if we take a look at the CSV side of things, the first example here is a parameter per column. So basically you'll see several rows in this report here. And the first row is going to be kind of the header row, so to speak. It's going to tell you what's in the following rows. And each column represents a separate portion of the data being collected by the telemetry report. The first column is going to be the report timestamp, and then you'll see broad packet sent, bytes received, bytes sent, so on. And so each additional row is going to show the actual content of that. Now, typically you would only have 2 rows in this, but this example is kind of showing where you have multiple reports being generated. In this case, they're being generated every few time periods. As you can see, the different report timestamp represents the different time that the report was generated. So this is a report that has actually multiple telemetry reports cached up. But you'll notice that the next column is going to be the broad packet sent, which is, the first row is 25,248, and then so on and so on. Then the next example of CSV is the parameter per row. So in this case, you still have a report header, so to speak, in your CSV, but it's a very generic one in that it's basically your parameter name, parameter value, and parameter type. And then each row is going to be one particular parameter inside the report. And you'll see that they all have the same report timestamp, so they're all part of the same actual report. All right. So next we get into how we actually reference the data model. There's several options here. You can do things like just specifying a complete path, which would be something like device.deviceinfo.software version. It's a very specific parameter that you want included inside the report. You can also do things like partial paths, where you potentially want all of the parameters underneath a specific object to be included in the report. So an example of that would be the device.deviceinfo.memory status object, providing all the different parameters underneath memory status to be sent in the report. Now you can also get into things like wildcarding paths, where if you have a parameter path that has an instance number and you don't necessarily want to narrow it down to specific instance numbers because either you want all of them or you don't necessarily know the instance numbers that might be on the CPE, you can definitely use wildcarded path, which is device.ethernet interface.star, so the wildcard character there, .stats. And so in this case, this is a wildcarded path that's kind of combined with a partial path, but you can also have a wildcarded path that's a complete path. So you may want a specific stat under there or all the stats. But essentially, this is telling the USP agent that when it generates the telemetry report to grab all of the Ethernet interfaces and all of the parameters under the stats object is put into that report. Now with USP, we've also introduced the concept called search expressions, which gives you the ability to kind of look across multiple instances of an object, but do so by using an expression that tells you which instances that you want to pull in. So for this example, we have device.ptm.link, and instead of just getting all PTM links, I just want to report on PTM links that are enabled. So they have the enable parameter set to true. That this pulls in all of the different stats for the enabled PTM links. So all the parameters under the stats object. So you can get really interesting search expressions going on. You can combine them with ands and ors and stuff like that. You can also do like unique keys if you know you want a specific instance of an object, or you can basically do things that are kind of search expressions that go across generic parameters. Now, a note on the paths and their validation. These paths are not validated at configuration time, so you can completely set up a bulk data collection profile that is pointing to a portion of the data model that may not be instantiated at the time of configuration, because the CPE is going to validate those paths at time of report generation. And so as the data model changes from over time, you can basically have a single bulk data collection profile that is able to handle the change of time of the data model. And so if something is not instantiated when the report goes to generate it. It simply ignores that path and continues the report generation. All right, now let's jump into alternative names. So, complete parameter paths are long. They can definitely increase the size of reports, and they're not always the best thing to look at when you're trying to, look at your data. So we provide a mechanism that's there to define a preferred name to use in the report instead of that complete parameter path name. So some examples of this, if you want to just do an alternative name for a full path, it's a very simple example here. So in your bulk data profile, this one is referencing the parameter device.mocha.interface.1.stats.broadPacketSent. And the alternative name that's provided is broadPacketSent. So when the report gets generated, instead of that long device.mocha. In the interface.1.stats.broadPacketSent, it's simply going to put broadPacketSent in there. So that's a very simple example, but you can also do partial paths here. So let's say that you wanted to collect, device.wi-fi.accessPoint.1.associatedDevice.10.stats and all the parameters underneath that. You could provide an alternative name that's a simpler, more concise name like Wi-Fi _AP1 _associate.10. And what the report generation is going to do is every time it goes to add a parameter that's under that stats object into the report, it's going to use that alternative name, that Wi-Fi _AP1 _associate.10. It's going to append a dot at the end of it and then put the parameter name, as you can see down at the bottom. In the examples for bytes sent, bytes received, packets sent, packets received here. So taking this a little bit further, what about wildcarding? It supports that as well. So in this case, the reference parameter is device.wifi.accessPoint.star.associatedDevice.star.stats. So we want all of the access points and all of the associated device under each access point. And we want the stats for those. That's what's going to be put into the telemetry report. And instead of that long path, we're just going to narrow that down to Wi-Fi _AP_soc. So what the CP will do on report generation is he'll look at each one of those wildcarded instance numbers and he'll put them in the path in sequence. So you'll start out with the Wi-Fi _AP_soc, and then the access point instance number will be appended after a dot, and then the associated device instance number will be appended after a dot. And then you'll put the byte sent or whatever parameter that might be at the end of that. And so you get something like, as you can see down here at the bottom, like for instance, access point 1, associated device 10, you get Wi-Fi AP assoc.1.10.byte sent, and so on. All right, and at that point, I think I'm going to hand this back over to Tzvi for a discussion on the next couple of slides before we hand it back over to Jason.
Yeah, thank you, John. Great. Let me just reshare my screen. Sorry. So again, thank you, John, for this great overview of bulk data collection. And just to finalize, I see that there are many questions coming, and it is interesting because we do see that bulk data collection has a great interest with a lot of the CSPs that we are engaging and working with. So I do believe that this would be revolutionizing the way that we are collecting information and getting more value-added information from the different services that are running and being provided within the home and running on top of the CPE. And I hope, just to finalize everything, before we will hand over and go over to the Q&A session, this mechanism is actually giving us the ability to distinguish, as I mentioned before, and having the separation and still collecting effectively data and managing the router, which is the core and most important element with every service provider. And I hope that the use case that I've shown before, describing how we can collect wireless LAN and also mesh. I know that there were a lot of discussions. I were looking a bit at the Q&A, and there are a lot of discussions about what can be supported and so on, and we will address them as time will give us. So I hope that this brings to the participants the entire information of how we can build this solution and more effectively continue and monitor the different services that are running. So what's in the future and what we want to expect in the future? We know that we will have more data sources. We will have more service deployed. We do see today the transformation that the CPE is becoming one of the most important elements within the home network with regards to smart home and cybersecurity, and also home security and all other applications that are running on top of that. This will require more analytic tools. This will require additional AI, ML integrations with our backend systems that will run on top of the collected data and analyze that. We will see this emerging as more and more devices are coming and supporting today USP. There was also a question in the QA, and I'm sorry, I'm getting ahead of things maybe, but yes, devices are coming today with USP agents. The Broadband Forum has also opened the OBUSP as an open source for those companies, device manufacturers, and so on that would like to utilize USP in order to drive their network faster. And it is all related to also to the cloud integrations that we continue to see evolving in this matter of data collection. It is very easy to create a device to cloud integration just by steering the information to any of your chosen cloud service provider that you want to use. And on top of that, you can build your own analytic applications, services, and other use cases that you feel are suitable for your end users. So before I will hand this over to Jason. So thank you all for joining, and we'll go over to the Q&A. Jason, going back to you.
Okay, thank you guys. I just wanted to throw this slide up one more time, so again people can understand what the components are and how this is kind of broken up. So if you're interested in learning about the kind of the how-to of the bulk data collection mechanism, that is in a annex or appendix of TR-369, and then obviously the objects and parameters for using bulk data are in TR-181 issue 2. There are bulk data test cases that are part of the certification program, and I don't remember how far OBUSP agent is on the bulk data support, John. I just to put it in the context of this webinar, I don't remember exactly what that is.
Yeah, the OBUSP agent supports H2 bulk data at this point in time, as well as the USP event notification.
Cool.
It's on the roadmap to support the MQTT bulk data collection as well, but that was actually just recently introduced in the USP 1.2 spec earlier this year.
Perfect. Awesome. Yeah, and we keep bringing up the work we've been doing with the Wi-Fi Alliance on Wi-Fi data elements. So be sure to get a good understanding of how that works with things like bulk data. Here's some resources that I'm going to leave up on the slide. We have a lot of questions, so I don't mind if we run over a little bit. I think that'll be fine. So let me just get started. So Tzvi and John, feel free to go ahead and grab the ones that you would like to answer live. I've tagged a few of them.
Okay.
There's a lot of them. The one thing I would like to do, the shared window was closed. Hold on, I'll bring that back up. The one thing I would like to do is address. There were a couple of them that I know people were asking about. The certification list is up and out there, and actually, Rhonda, if you can share that in the chat, that would be great. And yeah, let's go ahead and get started. So yeah, Tzvi, why don't you go ahead and grab.
Yeah, I'll try to grab some of these. I do see that there are a lot of questions coming, and that's great. So there's a question from Maud regarding, can we use ACS to manage mesh and Wi-Fi? Yes, you can. It is, as Jason mentioned before and was introduced in my presentation, you can monitor both mesh, the controller, and the satellites as well, the extenders, if they are upholding a USP and have the ability to communicate with the USP controller as well. What would require, again, another question, what would require at the residential gateway in order to support USP? So we mentioned before, OBUSP is one option that you can go as an open source client and integrate it with your residential gateway. I know that some vendors are doing that, and there are also vendor-specific USP agents that they are providing today. So you can, also always take a closer look with what other vendors are offering in that domain as well. What else? We can, how frequent data pulling or periodic intervals. So with bulk data, that's the coolest thing. I think we can have this, if I'm not mistaken, from a single minute or what's the minimum interval? I believe it should be from 1 second and above. But again, it depends on the device specification. If the device can support it with with that kind of a short period of time, that would be fine. And this would be supported on the device side as well. The collector is agnostic to the time of the pulling interval that you are setting for that purpose. It's just the amount of data that will be stored and processed on the collector side. Either if you're using HTTP or MQTT, it goes down to sizing the collector and having the right amount of data and connection that you would like to use for that specific architecture, right?
Yeah. All right. John, you want to grab another one?
Yeah, I'll take a couple here. See, one question, how is HTTP bulk data, and then they put in parentheses TR-157 different with TR-69 versus TR-369. First, to address the TR-157, the Broadband Forum has been working towards kind of moving everything that was previously defined in TR-157 into the various other protocols or TRs between TR-181, TR-69, and TR-369. So I think at this point in time, where the Broadband Forum is actually about to publish an updated version of TR-157 that marks it deprecated and basically tells where everything is actually moved to. But to answer the rest of the question, how is it different between TR-69 and TR-369? HTTP bulk data in itself is not significantly different between the two, other than potentially how you can define the references and being able to use search expressions, where TR-69 did not have that capability, one of the things that I covered in my slides. But that being said, TR-369 or USP has added additional options with the MQTT bulk data collection mechanism, as well as the USP event notification bulk data collection mechanism.
Yeah, and to follow up on that, there was another question about kind of like where to gain certain insights, and I think it's important to differentiate between the things that you would assign to a bulk data collection profile versus the in the Wi-Fi diagnostic commands that exist in USP. So an important point is that there's we took the path of defining any additional RPCs rather than defining them in the protocol. They're defined in the data model. So there's a lot of diagnostic actions that you can perform that are outside the context of bulk data collection, particularly in the Wi-Fi diagnostics tree, where you say, no, I want you to run this diagnostic right now and give me the results right now. And that's slightly different from bulk data collection, right, Sean?
Yeah. I can take another one. There's a question: are there plans to allow for dynamic selection of monitored parameters? For example, include in 15-minute transmission only if value exceeds a certain threshold. The Broadband Forum is actually working on something of that nature. There is kind of a there's already a thresholding mechanism that's defined as part of the USP data model that monitors for rise and fall and equals to certain values. And right now that thresholding mechanism just generates a trigger event message out to the USP controller. But there is some activity going on to see if we can expand that to potentially do other things, like potentially, enable a bulk data collection profile such that it would start collecting data. That way you can kind of tie related things together. Like if the temperature sensor goes over this, then start monitoring memory and potentially disk space and so forth like that to see what might be causing that temperature sensor spike.
So
Tzvi, is there
another? Yeah, I'll try to take also some. I know we have a bunch of them coming, so that's great. So there is a question, and today we're using an internal tool that we get Wi-Fi data every 6 minutes. Is it possible with bulk data? So the simple answer would be yes, of course. The more complex answer would be that definitely, because we don't use any additional, client application that you need to run on top of your CPE. The same USP agent that you're using today, or you will be using in the future, in order to communicate with that CPE, will be used in order to collect also the Wi-Fi statistics, as we shown before. It reduces dramatically the overall integration part that you need to do with new devices, integrating them in the system. Once you have just a single client that does the work for you, it actually simplifies the interoperability testing, the integration side as well. So I think that would be very much covered by the bulk data, by, again, OBUSP if you're using, or any other vendor-specific or related USP agent, which are also coming and arriving today as well.
Okay. There was a question. Actually, no, John, go ahead. There were a few more that you had grabbed.
Sure. Let's take, does the data sent raw or some aggregation operations are applied, like max, min, and average? Right now, the data is just sent raw. There is some discussion inside Broadband Forum to kind of figure out how to potentially do some aggregation operations. If you look at another portion of the Broadband Forum data model, you'll see a mechanism called periodic statistics. Periodic statistics is a concept it's been there for quite some time. It does have some aggregation capabilities, and the way periodic statistics works is it's intended to do kind of a frequent collection of data on the data model and then kind of put that into a comma separated list of values that will then be sent up on a less frequent basis. So there's definitely some discussions right now of how you can combine periodic statistics with potentiality of its data aggregation functions with bulk data collection, so that you can potentially do things like maybe collect data every 15 seconds and then report it up every 5 minutes with a comma separated list of those 15-second intervals. So there's definitely some work going on in Broadband Forum around that, and even potentiality of adding some of that data aggregator functionality to the bulk data. But that's all kind of in discussion right now. Hopefully we'll see some of that in the device 2.16 data model coming up, hopefully later this year.
Yeah, there was a question about, how you can separate the data collector out from the USP controller. Yeah, so remember that USP is defined to allow multiple controllers to control the same agent. So if you're looking to do in-band bulk data collection, you can absolutely have a separate controller that is meant for bulk data collection. However, for reasons related to security and the role-based access control that we've defined, a controller that wants to do the in-band bulk data collection over USB Notify has to be the controller that sets up the bulk data collection, which is totally fine. So you could have one controller that could be both operating on the same, MQTT system if you wanted to. You got one controller that's doing the rest of the management things or any other things that you would want to do. And then you could have one controller that is definitely dedicated to just the bulk data collection if you wanted to.
I don't know how much more time we have here, Jason. I see one that was, I was answering mostly at the start. I just scroll down a little bit. I see one, does USP integrate with Purple, OpenSync, RDK, et cetera? Are these solutions independent, complementary, competitive? If you look at Purple and RDK, I look at them as similar in nature. I think OpenSync is a little bit different because you actually have OpenSync integrated into things like RDK. So I look at this more from a Purple RDK perspective, and USP is already integrated into both OpenWRT, which is kind of the foundation of Purple OS, as well as RDK. There's integrations for USP agent to be in both of those.
Okay. All right. So if there's any questions that we don't get to, we will try to collect them among the panelists here and see if we can answer them over email, because it is getting late. But thank you very much for all the questions. I think this might have been the most questions that we've ever got on one of these webinars before. So thank you all for that very much. Stay tuned for some further webinars where we kind of go in depth for some TR-369 concepts like this. We want to make sure that there's enough educational materials out there and enough places to have this conversation. If you are a Broadband Forum member and you want to join the BBF Slack channel, there's plenty. That's a very easy way to ask questions about stuff like this. And by all means, if you want to be a guest, if you aren't a BBF member and you want to be a guest to one of our official meetings, feel free to reach out to Rhonda about that. She'll be very excited to get you started there. And we welcome everyone participating. We really do. Whenever, we want to make sure that everybody's use cases are incorporated and that if something that needs to be improved or fixed gets, that we get that information and contributions from you. We try to make it very fun too. So thank you very much. And we will talk to you all soon. Thank you, guys.
Thank you.
Thank you, everyone.